Hello, Algebra with Finance A students. Thanks for stopping by. This is going to be a review of Unit 4, Lesson 1, Scatter Plots. You see pictures of different types of scatter plots, and chances are you have seen these graphs in different math classes, possibly science classes. So we're going to go ahead and review what are they, how to make them, how to read them. Okay, so take screenshots. Feel free to pause at any time and take notes, and you can use your notes on your assignments. So scatter plots, what are they? They are graphs that show relationships between two sets of data. Okay, and we'll talk about those in just a second. So just briefly, how to make a scatter plot. Okay, uh, this requires 3 steps. Graph the data as ordered pairs on a coordinate plane. Okay, remember, let me just get a little pencil for you. Little pen here. Ordered pairs are in this format. Parenthesis, comma, and remember the first number is the x value and the second number in your ordered pair is the y value. Okay, so once you plot them, do not connect the dots. You're just going to see a graph, just like back here, of a bunch of points, dots. Use quadrant 1. It's the quadrant that is used most often for scatter plots because most data uses positive numbers. Okay, so that's how you make a scatter plot. So let's go ahead and take a look at this example. So we have a chart here of grams of fat and calories per serving. Look at this. Looking for some of your favorite foods. Potato chips. There's my pointer. Bread. Popcorn. It doesn't say what kind of popcorn, movie theater popcorn or just regular microwave popcorn. Ice cream. So it shows you the grams of fat and the calories per serving for each of the food items. Okay, so if you go ahead and make your graph, you want to have the x-axis. Okay, it's the first one in the column, so you're just going to have that be your x, the fat per serving in grams along the x-axis. And then along the y-axis is going to be the calories. Okay, so what they did was they looked at the calories per serving, and the lowest, if you can see, is 40. Okay, so that's your lowest. And then your most is 190 for the peanut butter. So your graph, okay, it's between the numbers of 40 and 190. They felt that going by increments of 50, actually by tens, okay, 50, 100, 150, 200. So therefore, every line is a 10. Okay, that would be the best way for you to graph your information. And then along the bottom, the fat per serving, they used also tens, by tens. But look at the grams of fat. The lowest is 0. Okay, that's the smallest amount. And the largest amount is 17. So is it necessary to make your x-axis by tens as well? Look what happens to this data. Look what happens to your points when you plot them. You don't get a good true picture of how the grams of fat and the number of calories correlate with each other. Okay, that's not a good picture. So what happens if you make your scales maybe a little bit different? Okay, let's take a look at this graph and then compare. Notice the difference between the two. We still have the calories along the left side. Okay, the y-axis, okay, that's your calories, and the fat per serving is along the x-axis. And the y is still increments of 10. Why? Because look at your calories. Those are large numbers, okay? Your fat per serving, they changed it. So each marking is worth 1. It's 1 unit. Okay, so the increments are by 1 along the x-axis and by tens along the y-axis, and that's okay. Now look at your graph. I'm going to go ahead and just circle the points, and look what happens. Can you see a correlation between the grams of fat and the calories per serving? What's happening as you are getting more grams of fat? What's happening to the number of calories? Look, they're getting higher. Here is 17 grams of fat, and that calorie amount is 190. And right there it is. And that was peanut butter. So how you make your increments on your scatter plot is a huge difference. Just compare the two graphs. Okay, it's same data. Count the points. You should have the same number of points on both graphs, but one is not very readable, and it doesn't give us good information. Okay, the second one, just because of the increments, gives us good information. Here's another one. Let's compare square footage of a house versus the price. Okay, so in your columns, the first column, square feet, that's your X. The price of the house is your Y. You want to take each one of these ordered pairs and graph them. And they already did that for you. Okay, so a 3,800 square foot home is selling for $324,900. A 1,400 square foot house is selling for $137,000. Can you say that the square footage, the price of the house depends on the square footage? Well, graph it and see. I'm just going to put a circle around our ordered pairs from the chart. As your square footage increases, okay, so look at the points. As the square footage increases, does the price of the homes also increase? And you can see that yes, it does. So in this one, you can safely say that the price of the house depends on the square footage. As the home's square footage increases, the bigger the house, the more money you're going to pay, okay, for the house. So great way to see how one factor correlates with another factor. Maybe there's no correlation, okay? But in this instance, in this town, the square footage, the less the square footage, the less you'll pay, okay? And like I said, sometimes that's not always true. Here's an example. Prices of SUV by age. So the age of your SUV is going to be your X's, and the price of the SUV is going to be your Y value. Okay, so X is the years and the Y are the prices. So let's just take a look. The age of the SUV, okay, they went ahead and the increments are by 1 along the x-axis down here. The y-axis, you've got a $1,400 about price of a car. So they went ahead and used 2,000 as their increments and then plotted their points. Let me take a look at these points. What is happening as your vehicle gets older? When it's a 2-year-old vehicle, it's kind of pricey, right? The higher the price. A 4-year-old vehicle, what's happening? Oh, nothing there. Let's go 7. What's happening? The price has decreased. Okay, and here's a 6-year-old vehicle, and look, you've got two prices. Maybe one is more souped up. It's got more bells and whistles on the car, so it's worth more. But what happens as the SUV increases in age, you can see my circle, the value of the car decreases. Okay, so we'll be able to tell some information about that. So it's not always a, a positive thing. This is a negative. The older the car, the less value it's going to be worth and the less money you're going to get. And that's what I've been mentioning all along is correlation, how the data is related. So if it's a positive correlation, one as one set of data increases, the other increases. Think of the square footage of the house. As the square footage of the house gets bigger, it's going to cost more money. The negative correlation, as one set of data increases, the other decreases, and it's going to go down and to the right. And then if there's no correlation, the data is just random and there is no relationship. So pause this slide and take a photo, and we're going to go through and practice some. Okay, so when you're looking at this and you need to determine whether it is a positive or negative or no correlation scatter plot, go ahead and put a circle. I kind of make it like it's an amoeba, right? And is it going, here's our three choices, down and to the right, up and to the right, or scattered all about? This one from left to right is going down. It's going down. That is what we call a negative correlation. Think of your car. The older your car, the less value it's going to be worth. Let's try this one. Put a circle around the majority of your points. And is your circle going up and to the right or down to the right or just all over the place? Well, this one is going up and to the right. So we call whatever two things we are comparing, we call this a positive correlation. Let's try this one. Look at this. I'm going to put a circle around and see if my circle is going up and to the right, down to the right, or all over the place. This one, there is no correlation. Okay, the grams of fat does not affect the number of calories. For example, well, we don't want 100,000 calories. So whatever the situation was, there's no correlation because the dots are all over the place. Okay, trend lines, line of best fit. This is how closely your data, how closely the line follows the data. And it helps us show predictions. So again, here is my group of lines or group of points, and I like to put a circle around it, or an oval actually, my amoeba around the points, and then I draw a straight line between the majority of the points. And yes, you can see your line is going up and to the right. This is positive correlation. Okay, here's your information. Trend line, put a circle around, and then the trend line goes through the middle. You're not connecting the dots, just through the middle of the majority of the points. And you can see it's going down and to the right. So we call that a negative correlation. I like drawing the lines because you're physically drawing the lines. Okay, let's try this one. Which of these pairs of variables, now notice there's no graph, just information, would you expect to be represented by a scatter plot with a positive correlation? That means when you graph your points, you put a circle and you put the line of best fit through the majority of the points, and it's going to go up and to the right. So a person's height and the person's grade on the math test, do those have anything to do with each other? Person's height? Absolutely not. How about the depth of the water in a pond and the amount of rainfall? The more water, the more rainfall, the more water. It is actually B. Okay, so now what I want you to do is go through C and D and determine why those two are not positive correlated. Thank you.